Welcome back to the course Asynchronous Programming in C#. My name is Philip Ekberg. Do you ever find that you have large collections of data where each item could be processed independently to speed things up, but you just don't know where to start? The next few modules will focus on teaching you how to break it down and introduce parallel programming. This will set you off to build really powerful and fast applications.
While the task certainly is a way to introduce a parallel operation, it's not automatically going to make use of all the available resources, such as the CPU cores or available threads. An asynchronous operation is operating in parallel, but the concept of parallel programming is slightly different. The biggest difference between parallel and asynchronous programming is that in asynchronous programming, we schedule a continuation. Later in this course, you will learn how to use these two principles together. Essentially, parallel programming allows you to break down a problem. It may be a large problem or a small one, but where each item takes a little bit of time to process. Doing so sequentially would take a much longer time than needed. You've learned how to use task.run and know that it relieves the current thread of work. This would certainly give the user the impression that it solves a problem faster. The goal, though, is to compute each part independently. This means we won't introduce one task, but each piece that can be solved at the same time would do so in a separate operation. Ideally, we'd get some help from the framework to determine things like the most appropriate degree of parallelism. Parallel programming in .NET can be achieved in a few different ways. There's the lower-level thread class, which gives you complete control of an actual thread. With complete control also comes great responsibility. You'd have to write a lot of code on your own to effectively introduce parallelism using the thread class. Then we have the task parallel library, which provides an abstract concept of looking at an operation that shouldn't block. The task should be the preferred way of running operations where you don't want to block the current context. With the task, you don't have to care about if it's a new thread or if it's reusing an existing thread. The task can schedule work on a thread pool, which may or may not spawn an actual thread. It may also reuse a pre-existing thread. This means that you don't have to use the lower-level threading and can instead rely on the framework and the language to give you some help. The task parallel library also introduces helper classes to easier introduce parallelism in your code. You've got a class called Parallel, which provides functionality for running a set of operations across the available resources, but also ways to easily convert a for and a for each loop into a parallel loop. When processing collections, you may have encountered link, and there's a very handy extension with the task parallel library, which provides a way to write parallel link. All the parallel helpers in the task parallel library are built on top of the task. When Microsoft introduced and started building these features, they were commonly known as the parallel extensions.
Obviously, there are also other libraries out there that will allow you to run background work and process data asynchronously. It's time to explore the parallel portions of the task parallel library.